Section 2.7 is on solving linear inequalities, and the great thing is we are going to solve linear inequalities pretty much the same way that we found solutions to linear equations. It looks different than having an equal sign. We have got an inequality sign, so here is an example of an inequality sign. That symbol is greater than when it's pointed that direction, open to the left and coming to a point on the right. That is greater than. So before we start solving linear inequalities, let's define the inequality symbols. Okay, greater than. Greater than is this symbol that looks like this, open to the left, pointing to the right. Let's use that in some examples. We've got, let's say 10 is greater than 5. Okay, we could also say 100 is greater than 0. We could say 25 is greater than -3. All right, those are all uses of greater than. Those are all true statements. What if we say something like x is greater than 5? Let's represent what that looks like on a number line. So here's a number line. I've marked the number 5, and we want to represent all values that are greater than 5 on the number line. So notice that the greater than does not include 5. We can say it's strictly greater than 5. It doesn't include 5. So we're going to use an open point on 5. It doesn't need to be that big, but just an open point. It's kind of hard to make a small point. There we go. It doesn't include 5, but it's going to include everything greater than 5. So we go from that point all the way to the right, because remember, to the right is the positive direction. And that arrow tells us it goes on forever without bound. We represent that with infinity, plus infinity. So this red shaded area on the number line represents x values that are greater than 5, strictly greater than 5. Now, greater than or equal to, we have the greater than, and the equal to, we put a little line underneath to stand for the equals. Now, because it includes greater than, the 3 greater than statements that we said for the example above, we can also use for greater than or equal to. We just need to add in that equal to symbol, just like that. Now, let's look at if we have x greater than or equal to, and let's say 0. And let's check this out on a number line. So here's our number line. We've got the number 0 marked. Because we're including 0, we're including this value, we can use a closed point. So now 0 is included. But it's x is greater than or equal to 0. So again, we're going to go to the right, which stands for the greater than direction. That arrow tells us it is going on forever. We use plus infinity to demonstrate that idea. So this red shaded arrow, including that point, represents x, all values, which we use x to stand for, greater than or equal to 0. Now let's look at less than. We use this symbol to stand for less than. So it's just the greater than symbol reversed. The pointy part comes first and the open part is on the right. So we can write down some less thans. We can write down 2 is less than 6. We can write down 100 is less than 200. And -7 is less than, let's say, 14. Now, let's say we want to represent x, value, all values of x less than 6. So again, we want to write that on a number line. So we're strictly less than 6, so we're not going to include 6. We put an open point on 6, and we want just values less than 6. So that goes to the left. To the left, we go to negative infinity. So we highlight everything going to the left. All right, so that arrow says that it keeps going without bound. It goes to this idea of negative infinity. Okay, last one is less than or equal to, so this is less than. And because it's equal to, we put that little line underneath. So we take our examples and we have 2 is less than or equal to 6, 100 is less than or equal to 200, negative 7 is less than or equal to 14. We could also add something like 11 is less than or equal to 11. Because it has this equal sign, we can include ones like that where it's just the same number on either side of that less than or equal to sign. Okay, so let's do x less than or equal to, let's do a negative number. Let's say negative 2, and now let's draw the number line. So negative 2, less than or equal to negative 2, we're going to be able to put a closed point at negative 2. And then less than, we go to the left, values of x that are less than negative 2, so we go to the left to negative infinity. Now let's look at one more inequality. This time we have x trapped in between negative 3 and 1. So we want both of these things to be true. We want negative 3 to be less than x, which if we flip that around, we would say that x is greater than negative 3. And we want x less than or equal to 1. Let's put this on a number line. So here's our number line. We want strictly greater than 3, so negative 3. So we'll put an open point at negative 3, and we want less than or equal to 1, so we want a closed point. So we want x to be greater than negative 3, so we go to the right for the greater than part, and we want x to be less than or equal to 1, so we go to the left. So it is just this shaded area in between negative 3 and 1. That represents 3 less than x, less than or equal to 1. Okay, now let's go to our example and let's solve this linear inequality. And we do that by undoing operations and getting x on one side. We have a 2x on the right side. Let's subtract 2x from both sides, and that way we get x all on the same side. Leaves us with 3x minus 4 greater than 1. And now we want to do undo the operations around that x. So we want to undo that subtraction of 4 by adding 4 to both sides. We get 3x is greater than 5. And then now we want to undo the multiplication by the 3, so we undo that by dividing by 3. That 3 cancels, and we're left with x greater than 5/3. X greater than 5/3. Okay, on a number line, let's write down what our set of numbers is. So if we put 5/3 right here, it does not include 5/3, right? It doesn't have that equal sign. So we put a circle around 5/3, and then we want to, because x is greater than 5/3, we want to go to the right. And we'll highlight or shade that area. So that is saying x greater than 5/3. Okay, there's another way that we can express this set of numbers. We've got this inequality saying any value of x greater than 5/3 is going to make that inequality statement true. We can use the number line to represent that set of numbers. And then the third way is what we call interval notation. Okay, interval notation is just a way to express a set of numbers. It is another method in addition to using a number line and using inequalities. For interval notation, we write the smaller value that x can be first, a comma, and then the larger value second. Around the values, we use parentheses if the value is not included. So that's going to show up with just strictly greater than or less than. If it is included, we use what we call a bracket that looks like this. And so if that value is included, we use the bracket. That's going to show up if we have a greater than or equal to or a less than or equal to. So let's look at this example. In inequality notation, we have 2 less than x less than or equal to 5. So 2 is in between 2 and 5. We can put that on a number line. We have 2 and 5. 2 is not included, so we have open circle. 5 is included, so we have closed circle, and we want values that are in between. If we want to write this in interval notation, we are going to write the smaller number, which is 2, comma, and then the larger number. In front of the 2, we want parenthesis or a bracket. Because we have a less than, 2 less than x, or x greater than 2, that means that we are going to use a parenthesis because that 2 is not included in that set of numbers. Because we have less than or equal to 5, we use a bracket. So that those symbols correspond to whether we use parentheses or brackets. So look at this one, -3 less than or equal to 8x less than or equal to 8. So for number line, we need -3 and 8. For this one, we are including both the -3 and the 8 because both of them are less than or equal to. And so we are including everything in between as well. The interval notation, the smaller number is -3, the larger number is 8, and we are going to use brackets on both sides because we've got less than or equal to for both of those. Now what if we have something like this where it's just one value and x is, in this case, less than that one value 5/3. Now we looked at this on a number line already, and we've got 5/3 here. It's strictly less than, so we are having an open circle, and it's less than, so we shade to, x is less than that number, so we shade to the left to -infinity. When we write this in interval notation, -infinity becomes what we plug in for the smallest value. So even though infinity or -infinity isn't a number, it can stand for that idea that it keeps going on in that direction. And then our largest value is that 5/3. Now, next to the 5/3, because it's x less than that number, it's not included, we use a parenthesis. We always use a parenthesis no matter what, with a negative or positive infinity. Let's look at this, x greater than or equal to 1/2. And I really like to do the number line because I feel like it gives a really good visual of the values that are in this set of numbers. So there's our 1/2. It is included because it's greater than or equal to, so we're going to put that closed point, but it is greater than or equal to, so that means we go to the right. So it includes all the values to positive infinity. In interval notation, our smallest value is the 1/2. And now we put in infinity or plus infinity for the larger value. It includes the 1/2 because it's greater than or equal to, so we use a bracket, and we always use a parenthesis by an infinity. Now we're going to run through some examples of solving linear equalities. We've got the steps there. Mostly we're following the same steps as when we are solving linear equations. We want to get x by itself. So let's subtract 6x from both sides. We can get the x's on one side. So we get -2x minus 8 greater than 2. Next, let's undo that minus 8 by adding 8 to both sides. -2x is greater than 2 plus 8 is 10. Now we want to undo that multiplication by -2, so we divide by -2. Now here's where our exception comes in. We are going to reverse the inequality because we're dividing by a negative. So we want to reverse the inequality. So we're going to reverse the greater than to, we're just going to flip it around, and it's going to become a less than. So those negative 2's cancel here. So we have x, flip that around, we get a less than. 10 divided by negative 2 is negative 5. So that is what our solution is in inequality notation, or XYZ homework might call that set builder. When you use the inequality like that, that is sometimes referred as set builder notation. And that's what you get if you just solve the inequality. That's what you end up with. Let's write it in interval notation. We have x less than negative 5. So that means that negative 5 is the larger number, which means that our smaller value, we're going to use negative infinity. So negative infinity to negative 5. We use a parenthesis because it's a less than, and it's always a parenthesis with a infinity. Okay, this one has denominators. It has fractions. So let's remember what we did when we were looking at linear equations. We wanted to clear those fractions, so we multiplied both sides by denominators. So that's what we're going to do here. We have a denominator of 3 and 4. We're going to multiply both sides by 3 and 4 over 1. And that's going to make those denominators cancel out. So on the left here, we can see those 3's are going to cancel out. We are left with 4 times 2x, and then that's less than. If we multiply the 3 times 4 times the negative 1/4, we're going to be left with negative 1 times the 3 because the 4's cancel out, and then we're left with 4x times 4. The 3's cancel out. So let's go through and simplify that. So 4 times 2, we get 8x, less than negative 1 times 3 is a negative 3, and then 4 times x times 4, 4 times 4, we get 16x. So we got rid of the denominators by multiplying both sides by those denominators. All right, so now we just have a regular inequality. We want to get the x's on one side, so let's subtract 16x from both sides. That's going to give us negative 8x less than negative 3. Now we want to undo the multiplication by negative 8. We're dividing by a negative, so we're going to want to flip that inequality so that less than becomes a greater than because we're multiplying by a negative 8. So reverse the less than to a greater than symbol. And negative 3 over negative 8 is the negative cancels out the negative, so that's a positive 3/8. Now, if it helps you to write down the number line to go to the interval notation, feel free to do that. So we're not including the 3/8. That should be 3/8. There we go. And so we do an open point, and then we want values greater than. So that means we're going to go to the right, to positive infinity. So when we write the interval notation, our smaller value is 3/8. And we're not including it, so we get a parenthesis. We go in the right direction to positive infinity. We use a parenthesis for infinity. So for this one, we've got x trapped inside the parentheses. So first thing to do is to distribute that negative 2. So negative 2x, and then negative 2 times negative 1, we're going to get a plus 2. Plus 3, less than or equal to. Let's combine the 3x and the negative 7x, and that gives us a negative 4x minus 2. Okay, let's get the x's on the same side. So add 4x to both sides. So negative 2 plus 4x, we get a positive 2x. Let's combine the 2 and the 3 and get plus 5, less than or equal to negative 2. Undoing the plus 5, subtract 5 from both sides. That gives us 2x less than or equal to negative 2 minus 5 is a negative 7. Okay, so we're only subtracting a number, we're not dividing or multiplying, so we can just leave the symbol, the less than or equal to, just as it is. Next step, we do want to divide by 2, but we're dividing by a positive 2. That cancels out, so we get x less than or equal to negative 7 halves. Number line, we have negative 7 halves, and we're including negative 7 halves, so we do a closed point. And we have less than, so that means we're going in to the left, we're going in the negative direction to negative infinity. In an interval notation, our smaller is negative infinity, the larger value is negative 7 halves. It's included because of the less than or equal to, so we use a bracket. Here's another one that has fractions and it has denominators that we want to clear. It has the denominators of 3 and 6. 6 has the factor of 3 in it. So what we want to multiply by is 3 and 2. So we're going to multiply both sides by 3 times 2, and think of that as over 1. So 3 times 2, which is like multiplying by 6. If we distribute that to x minus 3 over 3, the 3 is going to cancel top and bottom. We're left with the 2 times that quantity x minus 3. But that 3 in the denominator cancels out. And then both the 3 and the 2 are going to cancel with the 6 in the denominator of x plus 4 over 6. So we're just left with x plus 4, because the 3 cancels with the 3 and the 2 cancels with the 2. And so then that's greater than, the 3 cancels over here on the right, and we've got 5 times 2. Okay, we have a little bit of distributing to do, so 2 times x, we get 2x, 2 times negative 3, we get negative 6, and then plus x plus 4, greater than or equal to 5 times 2, which is 10. So let's combine things here. 2x plus x, we get 3x, and then negative 6 plus 4, we get minus 2, and then that's greater than 10. Let's add 2 to both sides. We want to get that x by itself, so add 2 to both sides. So we get 3x greater than or equal to 12, and then undo that multiplication by the 3 by dividing. So we get x greater than or equal to 12 divided by 3, which is 4. Number line, here's our 4. And we include the 4, so closed point, greater than or equal to, and it's greater than, so we go to the right. Interval notation, our smaller value is 4. It's included, so we use a bracket. It goes to positive infinity. Always use parentheses with infinity. Now this one has 2 inequalities. We can solve this like an equation, but now we've got 3 parts that we need to do the same thing on. So we can think of this as being a part, this as being a part, and this as being a part. So as long as we do the same thing to all 3 of the parts, we can maintain this inequality and solve this. So we want to get the x by itself. That's still the goal. So if we subtract 4, we can do that as long as we subtract 4 from the negative 2 and the 20. That results in negative 6 less than 2x less than or equal to 16. And now we want to divide by 2 to get that x by itself. So as long as we do that to the other 2 parts, that 2 will cancel. Negative 6 divided by 2 is a negative 3 less than x less than or equal to 16 divided by 2, which is 8. So on a number line, we've got our negative 3, we've got our 8. The negative 3 is not included, the 8 is included, and everything in between. For interval notation, our smaller number is negative 3, our larger number is 8. The less than is going to give us a parenthesis. The less than or equal to is going to give us a bracket. Okay, for this one we have two things to solve. We want one of these two things to be true, 2x minus 3 to be less than negative 6, or 5x plus 3 to be greater than or equal to 15. We're just going to solve each of these separately. So 2x minus 3 less than negative 6. To get the 2x by itself, we add 3 to both sides. So we get 2x less than negative 3, and then divide both sides by 2, results in x less than negative 3/2. Now let's do the other one, 5x plus 3 greater than or equal to 15. So subtract 3 from both sides, gives us 5x greater than or equal to 12. Divide both sides by 5. And x is greater than or equal to 12/5. And we're going to leave that as an improper fraction. That's just totally fine. Okay, now notice that these things cannot happen at the same time. We can't have a number that is less than negative 3/2 and greater than 12/5. So let's put those on a number line. Here's negative 3/2. Here's 12/5. If we put on x less than negative 3/2, we're not going to include that. We're going to go to the left because it's less than. And for x greater than or equal to 12/5, we are going to include it and then shade everything to the right because it's greater than. Now, we cannot have one number that satisfies both of those things. So that's why it's an or. So our solutions is that x is less than negative 3/2 or x is greater than 12/5. So that also means we can't write just one interval. So the interval for x less than 3/2 is going to be negative infinity to negative 3/2, but not including it. So a parenthesis, and then it goes from 12/5, including it, to positive infinity. Now, to show that these are part of the same interval, we put this u in between. So if you've done any set work, any learning about sets, or maybe like with probability or something like that, this u, that means union. Now, we're not going to worry too much about that. We just need to know, XYZ homework will want you to give things in interval notation. So when you have two intervals that don't overlap, but they both form, together they form the set of numbers that solve an inequality, we connect them with that U that stands for union. Okay, let's give this one a try. So let's get the x's on the same side, subtract x from both sides. All right, can you see what's happening here? We're going to have x minus x, which is 0 x's, and we get 8 is greater than 2. Negative 8 is greater than 2. Well, is negative 8 greater than 2? It's like not true, right? Because negative 8 is less than 2. So what that means is that there is no solution. So this inequality has no solution. There's no value of x that's going to make that a true statement.